more the C# syntax. And it's been like 2 weeks since we last did a XNA tutorial, so I'll cover what we did last time and make sure you understand most of the concepts we're going to cover today. So today we're going to discuss decision and OOP. Last time we discussed loops and all that good stuff. So last time we talked about Boolean operations, and I'll go back into that again for this one. And to the left is the operator, and to the right is what it is, or what it will do in your program. So the operator double ampersand, this stands for and you're going to have two Boolean expressions, or you can have as many as you want, but on one side of the and you'll have a Boolean expression, on the other side you'll have another. But you can have Boolean expression 1 and Boolean expression 2 and Boolean expression 3. It can go on forever. But as long as you have one on each side, it's okay. And means when one Boolean expression is true and another one is true, it'll execute a while loop or if block and all that stuff. Or is quite similar. Again, you need two Boolean expressions on either side of the or, and that means that one of them has to be true. If Boolean expression 1 is false, but Boolean expression 2 is true, it'll do the while loop and if block and all that stuff. The exclamation point is means not, so you can do not Boolean expression, and if the Boolean expression is true, the not will make it false. If the Boolean expression is false, the not will make it true. Not equals is quite similar. If something, you can have Boolean expression 1 does not equal Boolean expression 2. Or you can have x is not equal to y. That'll work too. Double equals, that stands for equal to. And again, that's like comparing one thing to another. If x is equal to y, or while x is equal to y, stuff like that. And then all the greater than, less than, greater than or equal to, less than or equal to. Those are pretty, you can get that from the name. If one's greater than another, it'll execute. If one's less than another, it'll execute. If one's greater than or equal to, and so on. Okay, so Boolean expression is a condition is a combination of an expression and a Boolean operator. We just looked at that over there. And the expression we covered last tutorial, that can be a variable, constant, returning method, and a combination of the above with math operations in between those two. That's what an expression is. Okay, so now let's go on to decision. The syntax between the greater than and less than are optional. Okay, so first we have if, and inside the parentheses we have Boolean expression, an end parenthesis. Then we have a curly brace, and then this is our if paragraph or if block. And any statement in this block will be executed if the Boolean expression is true. If it is not true, we go to the else, or else if. But that's optional. You can have an else, and you can also have an else if. And an else if is a combination of the two. If this does not execute, it'll go to here, and then it will check again if Boolean expression is true, it'll execute. So you can have you can have if, else if, else if, else if, and then if. You can have as many as you want in your program. Now we're going to go into a switch, but I'm going to go into the coding first. So, okay, let's demonstrate the if statement. I've generated a console application. You can get that from File, New, Application, File, New, Project, and select Console Application. And name it whatever you want. And we're going to demonstrate the if statement. So this is just going to be a very simple if to demonstrate the use of it. And I'm also going to give you a good idea of the Boolean expression too, since it's been about a week or 2 weeks since the looping tutorial. So we have, let's make two variables, int x, and let's set that as equal to 8. Now let's make another one, int y, and let's say that is equal to 10. So right now, we're going to test if they are equal to and not equal to. If, and then we have a parenthesis to put our Boolean expression in. So we're just going to test that they're equal. And to test that they're equal, we use double equals. Remember, the single equal is assignment, double equal is comparison. So if x is equal to y, we need to do something here. And here's a little trick. I'm only going to have one statement inside the if block. You do not need the curly braces if you only have one statement in that block. So that can cut your coding time and just general time and your general space in your program. If you have 500 if statements and they all have one line, you have an equal amount of curly braces. So since I only have one line, I do not need the curly braces. So let's generate our output, and let's just say x is equal to y. And I'm going to copy this, and I'm going to generate the else. I do not need the else if because there's only two things going on here. They can be either equal or not equal. And I put x is not equal to y. Now we need a console.read key to wait for the user to press a key before we quit the program. Press F5 to run it, and as you see, x is 8 and y is 10, so they are not equal. Let's see what we get. X is not equal to y. Now make them equal. Change whichever one you want and make them equal. Now we get x is equal to y. Okay, now we're going to do another thing. Change one of these two to whatever you wish, and let's test if x is greater than y. X is greater than y. And I copy this, make a new else, and this time we need the if because there's three things going on here. It can be either less than, it can be greater than, or it can be equal to. Yeah, that's right. Okay. So if it's less than, or if it's greater than, it's gonna go and it's gonna print it's greater than. If it's less than, it's gonna print it's less than. If they're equal to, or if they're not greater than or less than, it has to be equal to each other, so it's gonna print out x is equal to y. So right now, x is 5 and y is 10. It should print out x is less than y. And it does. Make one of those two, make sure x is greater than y, however you want. X is greater than y. Now make them equal to. X is equal to y. So that's an if statement, or if block, however you want to look at it. And you can use it to do good things in a program. Let's say you're making a shooter game and you want to test if your bullet intersects with an enemy. You need to remove the bullet and make sure the enemy takes damage. So every time the game loops, you're going to say, if this is intersect with this, check collision and remove the bullet and enemy takes damage. If you don't, move the bullet forward more. And also you're going to have another one to test to see if it's outside the world, or if it intersects with the building or anything else. You need to remove the bullet and draw a bullet hole, or draw nothing if it's out of the world. That way you have let's look at a space shooter. You have a ship right here, and you shoot, and so the bullet goes up like that, and while it's going up, you test to see if it collides with an enemy. If it doesn't collide with an enemy, you need to remove it when it reaches up here, or else you're going to have 500,000 bullets increasing in your memory, and it's going to create a memory hog for your program. So that's how you can use an if statement for your program. Okay, so decision switch. Again, the optional stuff is between that and that. Okay, so we start with switch, then we have opening parenthesis, an arithmetic expression, closing parenthesis, opening curly brace, and that starts our switch block or switch paragraph. And then we have an optional case value. And then on top of that option, we have an optional statements, and then we have another optional part, which is break. Then we have a default section. Again, this is the same thing as case value. Default is optional. Statements are optional too, and so is a break. An arithmetic expression. This is a single variable which can include an int, string, or character. And of course, there's some more options. Case value. This section is optional. You can have as many cases as you want. The statements inside the case block will execute if the arithmetic expression is equal to the value. So it's like multiple if statements. And it is always optional, or it is always recommended that you use a break statement. Default. This is equivalent to the else block and in the if statement. The statements in here will execute if nothing else has. That means if you have 20 case values and arithmetic expression does not equal those 20 values, it'll go to the default section. Now onto the switch statement. I generated a console application. You know how to do that by now, so create a console application and then follow me here. So the switch statement acts as a multiple if else, and all that stuff. It's basically multiple if statements in a pretty easily manageable manner. So it's going to operate just like an if. So to start, let's make two variables. Int x is equal to 10, and int y is equal to 50. Okay, so we can switch, and here we include just a single variable name and x. Now you can think of a switch as like a switchboard, and we have the curly braces. So the first thing up, we're going to test to see if case. Now we put the value of what x can be. So let's just say 10, just for the sake of proving stuff here. Now we have that's a colon, not a semicolon. Now we need to put console.writeLine. X is equal to 10. Okay. Now we have a break. And let's have another case, y. Console.writeLine x is equal to y. Break. Now I need to have a default. And let's just say x is unknown. Okay. So after that, let's add a console.read key to wait to quit. Okay. So let's press F5 to run it, and there are errors. Oh, you need a constant, not a. Let's just say 50. Okay. There were more errors. Default. I forgot the break in there. Okay. So now it should be able to run. X is equal to 10. Okay. Change X to something other than 10 and 50. I'll just say 20. X is unknown. Okay. Now change it to 50. X is equal to Y. Okay, good. Okay, so let's do something a little bit more fun. Let's delete everything except for the read key. Let's have int age is equal to enter your age. And then we're going to have a switch. And then let's say age. And we're going to test to see what ranking we are. Are we a child, teenager, adult, or an elderly? So let's just say, what are the very big important parts of aging? Well, 18 or 16, you get able to drive in most areas. 18, you're able to drink, and 21, you're able to vote. So let's do that. Case 16 console.writeLine. You are now old enough to drive. Break. Case 18 console.writeLine. You are now old enough to vote. Break. Case 21. WriteLine. You are now old enough to drink. Okay. So now that doesn't really do the purpose of this switch is to signify if we're a child, teenager, or an adult. And in order to do that, we need to have a default case. And inside here, we're going to have an if. If, let's just make a short, if age is less than or greater than 0, and we never went this complicated in a Boolean expression, but it's a good idea to put every Boolean expression inside of its own parentheses. It doesn't matter to the program, but it's better for our eyes to read it and interpret it. So if age is greater than 0, that's one Boolean expression. So that goes in its own parenthesis. And another parenthesis, age is less than 13. Let's just make that teenager. So with that, we're considered a child. So let's console.writeLine. You are a child. Now we need an else if. And it's a good idea to do else if. You don't want to do if, because that'll take up your programming, your computer processor time. If it does not equal that, or if it equals that, you're going to still test the next if, and you're going to test the next if. If you have else if, it will not test the next if because it's only else. So it's a good idea if you want to have multiple if to test individual things to use else if. Okay, so what else? 13 to 18. Let's just copy this. 13, 18. Copy that. You are a teenager. Okay, now an else, and we do not else it because there's just adult. And then you can go and say you're a baby or elderly or stuff like that, but I'm just going to do child, teenager, adult. You are an adult. Okay. So, you enter your age, then this will test if you're old enough to drive, vote, drink, and it should be fine. So let's run it. Oop. I always forget to break inside the default. Okay. And I forgot it in case 21 too. Okay. You're now old enough to drink. So, that's a quick and complicated switch statement for you. OOP, Object-Oriented Programming. This feature that makes C++, C#, Java, and others the best programming languages you can get. And we talked earlier about classes and to think of them as a blueprint, so now we'll learn how to use that blueprint for our program. First, we're going to talk about encapsulation. There's two others, inheritance and polymorphism. Encapsulation is the most important, so we'll cover that first. Encapsulation is basically what we have been noticing. And I say noticing because we haven't really done anything in OOP, but we've noticed we have a class at the beginning and we have other instances of OOP in our program already. Encapsulation enables a program to hide all of its classes and features from outsiders, and the only objects that can access that class and features. So there's a class definition or declaration. Access modifiers, that's an optional part. And then we have a class. And then we are followed by the class name, and this is user defined. You can say anything you want there, like your game name or anything you want. You're not restricted by it as long as you follow the naming convention, which is capital first letter in the name, capital every other word after that, and no spaces. So as you see, we have class name, we have capital C and capital M, N, and we have no spaces. So that's the naming convention for the classes. Then we have opening curly braces, and then we have the class paragraph started. Inside that, we have the 30 sections, the 30 most popular sections. There's others, but we'll go into that later on. So we have attributes. These are class level variables. Constructors. These are special methods that we'll go into a little bit later. And methods. And we messed with methods before, and it's basically the same thing as class level methods. Attribute section. In this section you put all the class level variables. These variables will be accessed with the objects of that class, or we'll notice in this tutorial we'll make class level variables be class level and not object level. And the objects of the class will act as a local variable, so whenever that block of code is done, the object will be gone. Constructors section. In this section you will add a special method that will be called whenever the object is created. And this special method differs from other methods, and we'll go into that next tutorial when we talk about making objects. Constructor grammar template, we'll go into that later. Method grammar template, we've talked about that. We have the access modifiers at the start. Then we have a return type, which are void, int, double, boolean, string, all that stuff. That's in a few tutorials back. Then we have a method name, and the naming convention on that is lowercase first letter in the first word. Then every other word after that will have no spaces but capital first letter. That's the naming convention for that. Then the parameters are optional. And then we have the paragraph and the statements inside that. Now what can be an access modifier? I'm only going to discuss a few right now, but there's a lot more that you can use. So when I say access modifier, there's public, private, and protected. Public is exactly what it says. Anything can have access to it. Private, this allows something to be a private level and can be accessed by something inside the class. Protected, this allows something to have limited private access and is only accessible from that class and all derived classes, like inheritance and polymorphism. Now when I say access modifiers with the S, I mean that it includes all the access modifiers that we discussed in the last slide. But also we can have sealed and static, and there's a lot more after that, like override. We'll go into more in depth on that on inheritance. But sealed means that this modifier specifies that this class cannot be inherited. Static we'll use a lot today, and we've been using it in our other programs. Public static void main. And this modifier specifies that a member does not belong to an individual object. Instead, it belongs to the type and class itself. So I'll demonstrate a class for you now. I'll name it methods, methods now only have an add method. It's just going to be a helper class for now. Okay, now for a brief introduction in OOP. And we're not going to make any objects in this tutorial. We're just going to make another class. And that class will be... we can have access to anything inside that class because we're going to use static. Okay, so right now I generated a new console application and I called it methods class. Now, as you can see, we have a class called program. We need to make another class. How do we do that? To the right, you see the Solution Explorer, and we see the C# green window type thingy, and underneath that we have properties, reference, programs. So right-click your project name, not your solution name, but your project name, and go to Add, New Item. I don't know if you can see that. Just go add new item. Now we have a list of items that we can add, and the class should be already highlighted. If it's not, select it and change class 1 to capital M lowercase ethods methods. And change this class to public class. Public class methods. And we're just going to have one method, or two, probably. And we're just gonna, I'm gonna just do add and subtract two variables. So we need a public static to signify its class level, add, and then we need an int x comma int y. And we're just gonna return x plus y. We're gonna return the value of x plus y. Oop. Public static int add. Now make another one. Public static int subtract. Okay. Int x comma int y. Return x minus y. Okay, so now I have two methods that we can use inside of our program. So how do we use them? Let's make two variables, int x, or three variables. Int x is equal to 30, or 4. Int y is equal to 10. Now, for the third one, int z, let's just do a shortcut. Is equal to, let's call the add or subtract method. How do we do that? We need a last name in the method call. As you remember, a method call we did a few tutorials back, we just said method, parentheses, semicolon. So we need a last name for that. A last name can be a class or object. Since we don't have any objects, it can be a class. So we start typing our class name, and we get it eventually here. As you can see, class method class dot methods. Now we're calling the class here, but that's the last name. We need the dot, and we need the methods. So let's add x and y. X comma y. Now let's print out z is equal to end quote plus z dot to string console dot read key. Okay. So let's run it, and 10 plus 4 is 14. Now just change add to subtract. 4 minus 10 is negative 6. Okay. So since this is fairly new to you, let's add a breakpoint and watch it work. We make x is equal to 4, y is equal to 10, z is equal to methods.subtract x comma y. So we step into, now we're in the methods class. It went into the subtract, and it made the parameters. And we simply return x minus y to the program class. We write it, we wait for the user to press the key, and we're done. So that's pretty much it for basic introduction to OOP. We'll go more in depth when we discuss objects and how to deal with them. But for right now, you can use your, if you have many different classes in your program, you can use your own methods class. Or if you have a project going on and you want to make a huge list of methods, you can. What I had to do for school is we started with a method to add, subtract, multiply, divide. That was our first project. Then our next project was to use those add, subtract, multiply, and divide into more. We're supposed to add modulus and other stuff. So instead of writing them every time in your new program, you can just copy and paste your methods class. It's very simple. And it can be simple for games. Let's say you have very basic methods like check collision and stuff like that. You can just copy and paste that to your next game and you've got that done. Saves you a lot of time. Well, that's it for this tutorial. Hope you enjoyed it. Next tutorial, we're going to discuss making objects and how to use private attributes with these objects. And we're also going to talk about inheritance. The tutorial after that, we're going to talk about polymorphism, and that'll be it for OOP. And that'll be it for the C# tutorial. So, 2 tutorials later on, we start with XNA stuff. And we're still not done with C#, but we're going to start XNA stuff, and then I'll go into C# stuff as we go along. So, hope you're going to enjoy the XNA syntax and enjoy making your own games.